So here is a chapter on measurement of length and motion where we can observe that the Deepa, a school student, is measuring her uniform. So while the tailor measures her uniform with the flexible measuring tape, she is able to observe that the measuring tape consists of various centimeters marked in that as 1, 2, 3, 4. It starts from 1 to 15 or it extends more than that. So this is used for measuring any kind of materials. So when she comes to school, she is discussing with her friends about this system. So out of that, one friend says that I have seen that his grandmother has been using the uh, arms for measuring the clothes. So at those times it was about the foot pound system where they used the humans arms without using any they used the body parts, either arm or foot, rather than using the materials or tools for the measurement system. So they observed that the number of handspans were slightly different with the number of students. That is, the different students had different arm spans, so that it was not proper or the universal way of measurement. They understood with this. So they guessed that at older stages this was kind of measurement which farmers or their grandparents used, but right now it is not an universal or the standard system. Why? Because for each individual it is changing. So they compared the length with the help of others. So in length the table they expressed in terms of handspan, therefore the handspan measurement was a unit. But at this case, say for example, if it's said to be 13 units with the help of handspan, it will be difference for the others, such as length of hand, foot, fist and fingers varies from person to person. So we need a richest, that is a standard unit. So standard unit for measurement you can observe here in a meter scale. Everywhere the meter scale is going to be the same, right? So this particular standard unit of measurement is said to be SI unit. So for length it is considered as meter and its symbol is small m. If 1 meter is equals to 100 equal divisions, that is 1 meter is equals to 100 centimeter. This is a basic conversion. So if you observe here a 15 centimeter scale which you daily bring in your stationery box, you can take and observe that the in between that 1 and 2 centimeter, that is said to be a millimeter. Each lines which represent a millimeter, and the longest line is said to be the half. Okay, now if you observe here, then the kilometer is said to be 1000 meters. So these are the basic conversion. 1 kilometer equal to 1000 meter, 1 meter equal to 100 centimeter, and 1 centimeter is equals to 10 millimeter. So you have to know this kind of division so that you can easily able to solve the numericals, basics of numericals. So now how do we measure the correct way of measuring length? So there are two pictures given, one is correct and incorrect, where you can observe that the scale should be in contact with the object along with its length, that too in a straight line. It should not be crossed line. If you do so, the line will measure in a wrong attitude or the wrong way. So you can observe here it is nearly 9.5 coming, between real it is somewhat different. So the measurement and length is different at different cases. So we can observe both are 9.5 only generally, but how do we say that it is wrong? It is actually a wrong way, because then in some cases it will lead to point or decimal measurements mistakes, so it will lead to deficiency in the accuracy point. Okay, next if we see how to measure the length of ends of the scale broken. So at such kind of measuring, when where there is no zero or if it is not clear, it can still be used. How is that? If the starting point which you use can be considered as the 0 1, or you can subtract from the point which you start. Okay, so you can do that way for measuring. So you can see the steel scale used for measurement and all. So you should be measuring any four objects and filling this in the column, that is the length of that object should be written here. Say for example, you can measure your height and put it here. You can measure another three people, your friends height, and put it and measure here. So I can write that object should not be a person generally. You can even use now some non-living thing as object, like your pencil box, your water bottle. All this can be put on the objects aside, and you can fill the length of that with the measuring tape or a scale you can use. So you can observe that measuring of the length of a curved line. Say for example, in some cases when curved line arises, you will be using a rope for measurement. So with that rope you can get along with the curved line, and then that thread which you have used can be fixed for measuring. Then describing the position, as you already know, the location can be described as with respect to the distance. You know, speed is equals to distance by time. So here we are not going to see about speed, it's going to be the reference point, that is from where you are going to start and from where you are going to end. So the point from which you are going to observe or measure is said to be the reference point. So it is already used in your PT periods, that is from the reference point you will be running to the point or the destination where you want to achieve that running race, or where you want to win that running race. Similarly, all these kind of positions or kilometers are with respect to the reference point you will be calculating. So this was all about today's chapter. Then if you observe motion, the second part of the chapter discusses about motion. Motion is nothing but when you push or pull, there creates a kind of movement due to the force. So it may lead to the change of shape, all these stuff. So when you drop an object, or when you move an object, when you move your body, so all this kind of locomotion is said to be motion. The types of motion, if you observe, you can see here circular motion is given, oscillatory motion, that is more predominant in your pendulum clocks. Then oscillating motion of a metal strip, this kind of experiment you would have done in your class, where you place a steel scale on the table and some weight on that, and when you hit that particular steel scale, you can observe this kind of motion, to and fro motion, that is said to be oscillatory motion. So here we can write that how the swing is having a kind of to and fro motion. Then that circular disc marigold is having circulatory motion, sliding motion in your slide. The seesaw is having up and down motion. And then so these kind of motions are the types of motion, that is rotatory motion, circulatory motion, oscillatory motion, linear motion. So curvilinear motion, which is there present in the case of swing or seesaw. So you can put forward that these are the types of motions and understand the concept. So motion is nothing but the movement of any object because of application of any kind of force, push or pull, or the movement of entire body, like in case of locomotion.